This is Designing the User Interface Strategies for Effective Human-Computer Interaction. Page 112, POTS 3.5, Theory Tabs that organize evaluation of user interfaces and guide design. Micro HCI theories focus on measurable performance such as speed and errors on multiple standard tasks taking seconds or minutes in laboratory environments. Design by levels. Start with high-level design and move to smaller objects and actions. Stages of action. Consider one behavior as they form intentions and seek to realize their goals. Consistency. Strive for consistency in objects and actions shown by words, icons, colors, shapes, gestures, menu, choices. Macro HCI theories focus on case studies of user experience over weeks and months in realistic usage contexts with great social engagement. Contextual support users who are embedded in emotional, physical, and social environments. Dynamic design for evolution of user behavior and users move through levels of mastery, performance, and leadership. Take in consideration that this might come out in the test. These are micro HCI theories or micro human-computer interaction theories, as well as macro HCI theories. I repeat, micro HCI theories focus on measurable performance such as speed and errors on multiple standard tasks taking seconds or minutes in laboratory environments. For macro HCI theories, we focus on case studies of user experience over weeks and months in realistic usage and contexts with rich social engagement. There are 3 evaluation of user interface guide design subdivisions of micro HCI theories, which are design levels. That is, start with high-level design and move to smaller objects and actions. And then stages of action, which considers the user behavior as they form intentions and seek to realize their goals, as well as consistency. Strive for consistency in objects and actions shown by words, icons, colors, shapes, gestures, and menu choices. This is what micro HCI theories have to worry about: design by levels, stages of action, and consistency. As opposed to macro HCI theories, which focuses on the case studies of user experience over weeks and months in realistic usage, context with rich social engagement. There are 2 subdivisions to this. The first one is contextual, which supports users who are embedded in emotional, physical, and social environments. And then the dynamic as well, which is designed for evolution of user behavior and users move through levels of mastery, performance, and leadership. Micro HCI theories focus on measurable performance such as speed and errors on multiple standard tasks taking seconds or minutes in laboratory environments. Macro HCI theories focus on case studies of user experience over weeks and months in realistic usage contexts with rich social engagement. Section 3.4, Theories, Chapter 3. This is the book, Designing the User Interface Strategies for Effective Human-Computer Interaction by Shneiderman. One goal for the discipline of human-computer interaction is to go beyond the specifics of guidelines and build on the breadth of principles to develop tested, reliable, and broadly useful theories. Of course, for a topic as large as a user interface design, many theories are needed. Carroll, 2003, Rogers, 2012, Vector, 2015. Some theories are descriptive. These are helpful in developing consistent terminology and useful taxonomies. I repeat that some of these theories are descriptive, and these are helpful in developing consistent terminology and useful taxonomies for objects and actions, thereby supporting collaboration and training. Other theories are explanatory, describing sequences of events and, where possible, cause and effect, making interventions possible. Still, other theories are prescriptive, giving designers clear guidance for their choices. Finally, the most precise theories are predictive, enabling designers to compare proposed designs for execution time, error rates, conversion rates, or trust levels. Another way to group theories is according to the types of skills involved, such as motor, pointing with a mouse, perceptual, finding an item on a display, or cognitive, planning the sequence of steps needed to pay a bill. Norman, 2015. Motor skills performance predictions are well established and accurate for predicting keystroking and pointing times. See Fitts Law, section 10.3. Perceptual theories have been success in predicting reading times for free text, lists, formatted displays, and other visual or auditory tasks. Cognitive theories involving short-term, working, and long-term memory are central problem solving and play a key role in the understanding productivity as a function of system response time. However, predicting performance of complex cognitive tasks, combinations of subtasks, is especially difficult because of the many strategies that might be employed and the many opportunities for going astray. The ratio of times needed to perform complex tasks between novices and experts or between first-time and frequent users can be as high as 100 to 1. Actually, the contrast is even more dramatic because novices and first-time users often make errors and are unable to complete the task. Web designers have emphasized information architecture theories with navigation as the keys of user success. Web users can be considered as foraging for information, and therefore, the effectiveness of the information sent of links is the issue. Paroli, 2007. A high-quality link relative to a specific task gives users a good scent or indication of what is and the destination. For example, if users are trying to find a demonstration of a software package and link with the text, download demo has a good scent. The challenge to designers is to understand user tasks well enough to design a large website such that users will be able to find their way successfully from a homepage to the right destination, even if it is 3 or 4 clicks away. Information foraging theory attempts to predict user success rates given a set of tasks and a website so as to guide refinements. This looks like an interesting word. I'm going to repeat it again. Information foraging theory attempts to predict user success rates given a set of tasks and websites so as to guide refinements. BOTS 3.4 has multiple theory types and the researchers designers consider when evaluating user interfaces. By theory type, there is descriptive. Describe user interfaces and their uses with consistent terminology and taxonomies. Then there is explanatory. Describes the sequences of events with causal relationships. Also, there is prescriptive. Offers guidelines to designers to make decisions. Then there's predictive. Enables comparison of design alternatives based on numeric predictions of speed or errors. By human capacity, there is motor, skill in pointing, clicking, dragging, or other movements. Also perceptual, which is visual, auditory, tactile, and other human sensory inputs. And there is cognitive, problem solving with short and long-term memory. Taxonomies can be an important part of descriptive and explanatory theories. A taxonomy imposes order by classifying a complex set of phenomena into understandable categories. For example, a taxonomy might be created for different kinds of input devices: direct versus indirect, linear versus rotary, 1 dash, 2 dash, 3 dash, or higher dimensional, and so on. Card et al. Period, 1990. Other taxonomies might cover tasks, structured versus unstructured, novel versus regular, or user interface styles. Direct manipulation menus from fill-in. An important class of taxonomies has to do with the individual differences among users, such as personality styles, convergent versus divergent, field-dependent versus independent, technical aptitudes, spatial visualization reasoning, and user experience levels, novice, knowledgeable, and expert. Taxonomies may facilitate useful comparisons, organize topics for newcomers, guide designers, and often indicate opportunities for novel products. For example, a task-by-type taxonomy organizes the information visualizations in Chapter 16. Any theory that might help designers to predict performance for even a limited range of users, tasks, or designs is a contribution. At the moment, in the field is filled with hundreds of theories competing for attention, while being refined by their promoters, extended by critics, and applied by eager and hopeful but skeptical designers. Carroll, 2003, 2014, Rogers, 2012. This development is healthy for the growing discipline of human-computer interaction, but it means that practitioners must keep up with the rapid developments not only in software tools and design guidelines, but also in theories. Critics raise two challenges. The first is, theory should be more central for researcher and practice. A good theory should guide researchers in understanding relationships between concepts and generalizing results. It should also guide practitioners when making design trade-offs for products. The power of theories to shape the design is most apparent in focused theories such as Fitts' law. It is more difficult to demonstrate for explanatory theories whose main impact may be in educating the next generation of designers. 2. Theory should lead rather than lag behind practice. Critics remark that too often a theory is used to explain what has been produced by commercial product designers. A robust theory should predict or at least guide practitioners in designing new products. Effective theory should suggest novel products and services while helping to refine existing ones. Another direction for theoreticians is to predict the subjective satisfaction or emotional reactions of users. Researchers in media and advertising have recognized the difficulty of predicting emotional reactions, so they complement theoretical predictions with their intuitive judgments and extensive market testing. Nall and Bilal, 2007. Broader theories of small group behavior, organizational dynamics, and sociology are proven to be useful in understanding social media and collaborative interfaces. Chapter 11. Similarly, the methods of anthropology or social psychology may be helpful in understanding technology, adoption, and overcoming barriers to new technology that cause resistance to change. There may be nothing so practical as good theory, but coming up with an effective theory is often difficult. By definition, a theory, taxonomy, or model is an abstraction of reality and therefore must be incomplete. However, a good theory should be understandable, produce similar conclusions for all who use it, and help to solve design problems. This section reviews a range of descriptive and explanatory theories. 3.4.1 Design by level theories. One approach to developing descriptive theories is to separate concepts according to levels. Such theories have been helpful in software engineering and network design. An appealing and easily comprehensible design by levels theory for interfaces is the 4-level conceptual semantic syntactic and lexical theory, Fali et al., 1995. 1. The conceptual level is the user's mental model of the interactive system. 2. Mental models for image creation are paint programs that manipulate pixel and drawing programs that operate on objects. Users of paint programs think in terms of sequences or actions on pixels and groups of pixels, while users of drawing programs think in terms of sequences of actions on objects and groups of objects. Decisions about mental models affect each of the lower levels. 2. The semantic level describes the meanings conveyed by the user's input and by the computer's output display. For example, deleting an object in a drawing program could be accomplished by undoing a recent action or by invoking a delete object action. Either action should eliminate only a single object and leave the rest untouched. The syntactic level defines how the user actions that convey semantics are assembled into complete sentences to perform certain tasks. For example, the delete file action could be invoked by dragging an object to trash can, followed by a click on the information dialog box. 4. The lexical level deals with device dependencies and with the precise mechanisms by which users specify the syntax. For example, a function key or a mouse double key click within 200 milliseconds. This 4-level theory is convenient for designers because its top-down nature is easy to explain, matches the software architecture, and allows for useful modularity during design. Over the years, the success of graphical direct manipulation interfaces has shifted attention up to a conceptual level, which is closest to a task domain. Parrish, 2015. For example, designers of personal financial interfaces often use direct manipulation interfaces. These interfaces build on the user's mental model for writing checks by showing the image of a check for users to fill in. The same image of a check serves as the query template, so users can specify dates, pays, or amounts. Increasingly, actions are shown by novel visual representations, for example, a trash can for deletion or play button to start playing a video. Users have to learn the semantics E.G. that they can recover a file by opening up the trash can or to stop a video by clicking on the pause button. But if the designer chooses familiar objects to associate with the actions, users can quickly acquire the correct mental model for operating the user interface. Of course, Users also have to learn the syntax by dragging objects or clicking to initiate the actions, but these mechanisms are commonly used and have become well known. The idea of design levels is successful even in more complex systems. With many objects and actions, for example, the human body can be discussed in terms of neural, muscular, skeletal, reproductive, digestive, circulatory, and other subsystems, which in turn might be described in terms of organs, tissues, and cells. Most real-world objects have similar decompositions: buildings into floors, floors into rooms, rooms into doors, walls, windows, and so on. Similarly, movies can be decomposed into scenes, scenes into shots, and shots into dialogue, images, and sounds. Since most objects can be decomposed in many ways, the designer's job is to create a comprehensible and memorable levels of objects. In parallel with the composition of objects, designers need to decompose complex actions into several smaller actions. For example, a baseball game has innings, pitches, runs, and outs. And a building construction plan can be reduced to a series of steps such as surveying the property, laying the foundation, building the frame, raising the roof, and completing the interior. Most actions can also be decomposed in many ways, so again, the designer's job here is to create the comprehensible and memorable levels of actions. The goal is simplifying interface concepts while presenting visual representation of the object and actions involved is at the heart of the direct manipulation approach to design. Chapter 7. When a complete user interface design has been made, the user's task can be described by a series of actions. These precise descriptions can serve as a basis for predicting the time required to perform tasks by simply counting off the number of milliseconds needed to complete all the steps. For example, resizing a photo may require several mouse drags, selections of menu items, clicks on dialog box buttons, and typing of dimensions, but each of these actions takes a predictable amount of time. Several researchers have successfully predicted the time required for complex tasks by adding up the times required for each component action. This predictive approach, based on goals, operators, methods, and selection rules, or GOMS, decomposes goals into many operator actions and then into methods. Users apply selection rules to choose among alternate methods for achieving goals. Card et al., 1983, Baumeister et al., 2000. The GOMS approach works best when the users are expert at frequent users who are working on their own, fully focused on the task, and make no mistakes. Advocates of GOMS have developed software tools to simplify and speed up the modeling process in the hope of increasing usage. John 2011, critics complain that broader theories are needed to predict novice user behavior, the transition of proficiency, the rate of errors, the retention over time. Designers have discovered that using the design by levels theories forces clear definitions of the high-level objects and actions, which are gathered from listening to a language used in the task domain. Music can be thought of as songs organized by artists, albums, and genres. Users can find a song and then play it or add it to a playlist. The clarity of this conceptual structure earned it a patent as stimulated multiple commercial successes.